Hello everybody, today's video is about fatty acids breakdown. So we're going to talk about firstly like the basics of what a fatty acid is. Secondly, we're going to do a nomenclature, so how to name them. And lastly, we're going to talk about its relation to temperature and its melting point. So firstly, what is a fatty acid? So they are a hydrocarbon, they're a bunch of hydrocarbons linked together with carboxylic head group. So you can see here, this is a long hydrocarbons, and this is the carboxylic head group. So the most important thing about them is that the fatty acids, they differ in two things. First, the length. As you can see, the lengths of these two examples we have here, 1 and 2, they have different lengths. So that's one way they differ. But they also differ in the degree of saturation. So what does that mean? So that means they differ in the amount of double bonds. So you see here, this one has 1 double bond right here. This one's 0 double bond. So they differ in those two aspects. So if you have a saturated fatty acid, that means it has no double bond. So this one right here is a saturated fatty acid. If you have an unsaturated one that has only 1 double bond, this is unsaturated. And what if you have more than 1 double bond? Then it's called a polyunsaturated fatty acid. So that's important to know. Secondly, so now we know it differs by its length and the degree of saturation. If you want to think about this nomenclature and how to name them, we have to make sure we're super specific. So the 3 things to know, the 3 things that affect this nomenclature is also its length, and then if it does it have double bonds, and lastly, if so, where are double bonds? Where are the double bonds, I should say. Where are the double bonds? So this format is how you're going to do it. So this is how it should look like. First, the number of carbons. And then the number of double bonds. If it has nothing, you just put 0. And then you put a triangle, and then up top you write the double bond position. Okay, so it doesn't seem too bad. Let's look at these 2 examples we have here. And also important, one more rule, when you're counting the number of double bonds for the position, you start the carbon number 1 is the head group, the carboxylic head group. So that's carbon number 1. So now we know that, we can do this example fairly easily. So let's look at the saturated one first. So this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So that's the number of carbons we have, so we put 16. Put the colon, and then number of double bonds, there's no double bonds. This is 0 here. So this is the nomenclature for this fatty acid. So let's try the other one. So we have to start here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is important. This is where the double bond is. 10, 11, 12, 13, 14, 15, 16, 17, 18. This one's similar. We start off with number of carbons, so there's 18, colon. How many double bonds does it have? It just has 1 here. And then the position of this double bond is the 9th one. Let's just say there was another double bond here. Then we just put a bracket, a comma, and then 15. But there's not, so that's just in case if it has 2, and then obviously we put 2 here instead. So now that we know that part, I'll quickly talk about its relationship with temperature. So the longer the carbon chain is, or like the length of the carbon chain, that means it has a higher melting point. So longer carbon chain, or less its length, equals higher melting point. So it can withstand more temperature. But there's a major like asterisk with that. But if it has a double bond, so if then it's automatically going to have a very low melting point with equals low melting point. And this one takes precedence. So then if you have a long carbon chain but with a double bond, its melting point is going to be really low compared to one that's medium length and has no double bonds. That one's going to have a higher melting point. So it gets kind of confusing, but it's first I would look, does it have, the first question you always ask when looking at melting point is there double bonds? And the more double bonds equals lower melting point. Because if you think about it, when fatty acids come together, if there's more, if they're not coming together straight on, then there's less force keeping them together. So I have a couple examples here. So out of these 4, which one has the highest melting point? So 24, 0, 22, 0, 26, 1, 3, lastly 24, 1, and 3. So I'll give you a second to pick your answer. But the correct answer here would be this one. It will have the highest melting point because its longest length without a double bond. Because this one does have it is longer, but it has a double bond. So it's gonna have a lower melting point. Secondly, let's do one more example. So which one has the lowest melting point for this one? So this is also gonna start with 24, 0, 24, 1, 3, 24, 2, 4, and the last one, 24, 3. They all have the same length, but okay, I'll give you some time to pick an answer. Okay, so the answer for this question would be this one. It has 3 double bonds, which is the most out of any of them, so it's gonna have the lowest melting point. Okay, hope you guys learned a lot from this video. If you have any questions, you can leave it in the comments. And yeah, that's everything about fatty acids. Hope you guys have a great day.